Hello everyone and welcome to a new IBMi RPG sample video. Today's video is great for both beginners and those who are looking to understand the different ways we can use data structures in RPG. As you probably know, RPG offers some incredibly powerful features when it comes to data structures. Honestly, I don't know many other languages that give you this much flexibility and control. I'm going to walk you through the basic types of data structures, and for each one I'll show you a working example. Let's go. Using data structures in RPG is basic. That's something for everyone. I'll try to show you the basics and with that a small example of it. Well, I have prepared a simple basic program here and you can see it in the screen using Code for I, and I'm going to write here the different examples that I'm going to show you in this video. Well, number one, arrays. Well, like in most other languages, arrays in RPG let you group multiple values of the same type. In RPG, there are simply basic types with an associated dimension. Here's an example. We can define an array as this. Let me make it bigger so you can see it better. So we can have a type character for this field, and we're gonna give a dimension. Okay, so for example we can access to every position this way. And later we will need to go through the array. Oops. This way. Okay. Well, you can also create arrays with a variable number of elements using auto or bar. Okay, I'm here using a fixed number of elements, but also we can change this and we can put here, for example, auto and the maximum number of elements, and we can do the same as this, but we can initialize this way, and we can add the elements this way, and it will automatically put the number of index to every of the fields. So we can do something like this and it will work in the same way. Okay, lm lets you retrieve the actual number of elements at any time. Okay, you will not need a field to store it. It's super useful. Well, number two, unnamed data structure. Well, these are structures without a name. They are great when you just want to group a few fields without needing a structure reference. Here's how it looks. Let me remove this, and you will have something like this. I'm not going to give a name, and we can put here the fields that we want to put. Okay, for example, a name, an address, or an age. Okay, and how can we refer to every field? Okay, in that case I will use directly the field. Okay, for example, Peter address is gonna be Fake Street number 123, age 35, for example. Okay, so we don't need to refer to the structure at any time. Okay, we can refer to the field directly without needing any prefix. Well, number three, named and qualified data structures. Well, now if you want to organize fields under a common name, you can define a qualified structure. Okay, so in this case we can add a name, for example client. We can say qualified, and this way we are going to access to every field this way. Client name, client address, client age. Okay. Of course, you can also use arrays inside a qualified structure. Okay, for example, we can add here, I don't know, if imagine we are defining here products or a product. Okay, the ID of the product, the description, and for example the price, and we can add here, I don't know, for example the size. And this product can have more than one size. So for example we can have 10 sizes, 10 different sizes. So we can write product ID, that is going to be the number 1. Let me remove this. Description is a t-shirt. Price is, for example, 10.5, and we are going to have size 1 is going to be medium, it's going to be large, for example. Okay. Well, remember that when declaring an array inside the data structure, the dimension must be fixed. Okay, we cannot write here auto or bar. We cannot do this. Okay, we will fail. Well, number 4, manual split and overlays with arrays. Well, this isn't a new type of structure, but a very clever way to split and access ports of a long buffer using pos. Take a look at this. Let me remove this and let me write something like this. I'm using here an unnamed data structure. Okay, let me write here a big field, for example of 1000 positions. Okay, and imagine that I have a subfield number 1 of 1 character, 10 character length in position 1. Okay, this position refers to the position of the entire structure. So sub 1 is gonna be the first 10 positions of big field. Okay, because big field is the position 1. Okay, so if I write here sub 2 of 10 and 11 here, it is gonna be the next 10 characters of the structure. Sub 3 position 21, the next 10 characters. Okay, we can write here all the sub fields to fill the subfield field. Okay, so if I write something like this, sub big field is equal to John Smith, that is 10 character length, and also we can write here 12 Main Street, that is 10 character length, and we can write here the state, for example, I don't know, something like this. Okay, well, this way we can write this, and this way we're going to get this, this, and this. Okay, this lets you split a field without needing of a substring or parsing a by character. Okay, well, you can also use a positional array for the same idea. Okay, imagine, for example, let me remove this and write something like this. Again, an unnamed data structure. This is the same as before. Okay, a buffer, and we can do something like this: entries, character 50, dimension 20, position 1. So we are going this way to split this buffer into 20 different fields of 50 character length. Okay, and we can access them using entries directly this way. Imagine we can write buffer is equal to, this is a buffer of a lot of characters, I don't know. Okay, then we can write entries 1, entries 2. Okay, we can write all the entries, and this way we are going to write here the first 50 characters. Okay, and here the second 50 characters, and so on. Okay, I think this is nice and clean. Well, number 5, nested structures. Well, you can nest structures inside other structures to create hierarchies. Here's an example. Let me write invoice data structure. Okay, that's gonna be a qualified structure, and we are gonna have a number and a substructure that is gonna be a customer, and here we can write the name of the customer and the city of the customer, for example. Okay, so this way we are going to have an invoice number that's going to be the invoice number 1, the invoice customer that is going to have a name, Maria, and city that's gonna be Madrid. Okay, just like with subfields, you can also define arrays of substructures as long as the number of elements is fixed. Okay, we can write here something like this. Okay, and then if I write something like this, then we will need to access to the customer using a dimension number. Okay, this way. Number 6, external structures from physical files. Well, you can pull the structure directly from a physical file using EXTNAME or LIKEREC. Okay, so for example, we can do something like this. Imagine that I have a file named clients this way, and we can have a client DS with, and we can write external name clients, and this way client DS is gonna have the same structure, the same number of fields, the same data type fields of the file declared. Okay, so we can do something like this: read clients client DS, and if it is not end of file, we can write name, I don't know, all the different fields. Okay. So this way we are giving to the data structure client DS the same structure that the physical file has. I mean, the same fields with the same data type. Okay. Well, you can do the same using LIKEREC, which is even cleaner. Okay. So for example, we can imagine that clients has a record name R clients. Okay. We can do something like this: client DS LIKEREC client R client. Okay, and this way we will work in the same way. Okay. Well, and the number 7 occurs structures. Okay. Finally, the classic occurs structures. Well, these are older and IBM doesn't really recommend this anymore, but you still might see them. Okay. How we can use them? Well, imagine address DS, for example, that is a qualified structure, and we can add here occur number with a number. Okay. Well, this works like a different data structure. Okay, a dimensional data structure. We can have here a strict and city. Okay. Well, how can I access to every of the different positions? Well, to do that, we can use occur. Okay, and we can put here the name of the structure and the name and the number of the position that I'm going to use. Okay, this way I'm activating this position, and then address DS street, this refers to the first position because I have right here occur is equal to 1. Okay, for example. Okay, so if we want to access to the second position, then we have to write a number 2 here. For example, we can write here Sunset Boulevard, Los Angeles. Okay, and imagine we want to write all of the information that we have in the occur. Well, then we are going to have to do something like this. Is equal to I for example, this way. Okay. Well, instead of accessing via index, you switch the active record with occur, as I said. Again, this is more of a legacy feature. Using qualified structures with arrays is usually better and more flexible. Okay. So as you have seen, RPG offers a wide variety of ways to define and use data structures, from simple arrays to overlays, nested structures, and external definitions from files. There's a lot more we could explore, but this should give you a solid foundation. If you use data structures in a different way, or you've got an interesting trick, please share it in the comments. We're all here to learn from each other. I hope you liked the video and that it was useful to you. As always, remember to like and subscribe to the channel and check out my other RPG content. See you on the next video, and thanks for watching.